Welcome to Mr. Garofalo's podcast. This is a special addition to the compound inequalities lesson. In this podcast, I am answering or attempting to answer an important question that was asked at the end of one of the classes today, and we didn't have time to talk about. Then the question had to do with when we write the compound inequalities for intersections, is there any other directions that these symbols could face instead of just seeing it like this? So this is what we looked at in class today, where we have the intersection of two inequalities. And I give you an example here. This is x is less than 7 and x is greater than 3. So you'd see open circle on 3, open circle on 7, and they're all the numbers that are in between. Remember, anytime we write a compound inequality like this, it's an intersection, or think of it as connecting them with the word and. I think that's really important to keep in mind. So let's look at what happens when we change the direction of some of these symbols. So let's say that we're facing this way instead. Okay? So 3 is greater than x, and x is greater than 7. If you break that apart, that's really the same as saying, okay, 3 is greater than x, or really x is greater than 3 from this piece here. X is less than 3, excuse me, and then this piece here, x is greater than 7. Now if you think about that, that's not possible. How could a number be larger than 7 but smaller than 3 at the same time? And on the graph, you would see if we had x is greater than 7, would look like this, and x is less than 3 would look like this. So there's no way that there's an intersection of these two sets. It's not possible. So you could not have the intersection of two sets ever being written like this, because there's no elements that are common to both. What about if it looked like this? Okay, here we have 3 is less than x, and x is greater than 7. So if we broke it apart, it would look like this. Basically saying that x is greater than 3 and x is also greater than 7 at the same time. So let's look at that on a number line. So we know what x is greater than 7 looks like. Looks like this. That x is greater than 3 looks like this. So we get this kind of overrunning inequality. But what I want you to look at is in the middle, where the black and the red shading don't overlap with one another. These numbers like 5 and 6 and 5.5 and 4 and 4.25 and all these real numbers, all these numbers right in here are unaccounted for. Okay, those numbers right in there are not part of any overlapping region. Okay, so this could not be an intersection. You could not write it like this because there are some values that are left out. What about if it looked like this one here? This is the last possibility, where we have 3 is greater than x and x is less than 7. If we broke that one apart, it would look like this. So x is less than 3 and x is less than 7. Well, we know what x is less than 3 would look like. And x is less than 7 would look like this. Okay, once again, notice we do have some overlapping regions, but all these values in between 3 and 7 are unaccounted for in the intersection. Okay? There's no overlap. For instance, 4 couldn't be a number that is less than 3 and less than 7 at the same time. It's only less than 7. Okay? So once again, we couldn't connect these with the intersection. We couldn't write it like this. Okay? For the last two problems, we could write them as the union of two sets. In other words, we could say, well, x is less than 7 or x is less than 3. And in that case, then that would cover everything, because anything in this black would be covered up. Okay? And really, we would just say then x is less than 7, because the black kind of covers up everything that's in the red anyway. Same thing with this one. We could say that x is greater than 3 or x is greater than 7. But notice, when we say x is greater than 3, that black shading is going to cover up all the other numbers. So we would just say this is just all the numbers greater than 3. Okay, so for these last two, you would have to use a union to connect them. So once again, this would be the only acceptable form for compound inequalities as the intersection of two of them. This is certainly not possible at all. Here we have some possibilities, but we're leaving out values, and the same thing here. So hopefully that is a little bit of clarification to that question at the end of class. Have a good day. See you in class.